Hi, this is Mrs. Ringrose, and we are back at it again with our videos, doing some quick vocabulary as a prerequisite so you can get into class and do the fun stuff. Now, I know I opened up this chapter or this unit with another section, and so you're learning, you're backtracking, and you're going back and doing this section so that we can write and solve proportions together in class on the similar figures that we're going to discuss. So again, our objective today is to be able to write and solve proportions and write ratios and simplify those because goes right into proportions. So a ratio is a comparison of two numbers, and we usually express it as a fraction. We would say, if we know that this is a comparison, we would say A to B. Sometimes you see a ratio written like this, especially when it's something called an extended ratio, and that might be more than two things, like, for instance, the angles of a triangle or the sides of a triangle. Slope is the ratio you're probably most common with, right? Because slope is the ratio of the change of y over the change in x. Another ratio that you are very familiar with, and you probably don't even know it, is pi. Pi is actually the ratio of a circumference of a circle to its diameter. And that's how they calculate pi, is they get a circumference, they divide it by the diameter, and boom, you get pi. Every single time. A proportion is simply you take two ratios and you set them equal to each other. So if you've created your ratios correctly and you know that certain shapes are similar, then you can turn it into a proportion by setting them equal. Then we've got these two words that kind of go together. And again, if I'm going too fast, just pause me and make sure you get the notes, and then or you can go back and listen. So when you go to solve a proportion, you probably heard this before. You go ahead and cross multiply, right? So it looks like cross. And so A times D equals B times C. And we actually have vocabulary for that. The ones on this side is called the extreme, and the ones that end up on this side are called the means. And so it's just a little bit of maybe interesting vocabulary for you. And that goes along with what's known as a geometric mean. So a geometric mean is usually when you're using the same measurement and it goes in into both of the spots for the means of a proportion. So notice this example, I have A to X. So A to X is set equal to X to B. And what happens is you end up with an X squared. And so we're going to practice how to solve geometric means as well. All right, I'm going to move on to the next page. So if you need anything, make sure you pause it, and I'm going to get going. All right, so these are the kind of problems that you're going to be expected to be able to do on your own. So I'm given a figure here. There's a rectangle. I'm told that the width is 7 feet. I'm told that the length is 14 feet. And I'm reading the word problem. It says state the ratio of the width to the length. So whenever I do anything with ratios or proportions, in order to keep everything organized, I put things in words first. And you're going to see me do that over and over again. All right. So then I know that width goes on top because it's stated first in the word problem. And so the width of this quadrilateral is 7. And the length of this quadrilateral is 14. And I know that both those numbers have a common factor, so I can go ahead and simplify this to 1/2, and you're expected to do that. All right, so that's one common example. Another common example might be that you are dealing with two similar figures and you want to state the ratio between them. So again, triangle ABC is going to be on top because that's stated first, and triangle DEF will be on the bottom. And the side length of ABC is 2 of that equilateral triangle, while the side length of the other one is 1. So I'm done there. The ratio is 2 to 1. And then sometimes you're asked to simplify. So, we just simplified up top, but when they're written a different way, you need to be able to know how to do those. So 63 meters to 6 meters, they both have a common factor of 3. So I'm going to simplify that 3 out of there. And my new would be 21 meters to 2 meters. And that is simplified. And the last one, you might be good with just saying it's 1/4, But when you are simplifying ratios, you need to have same units if you're talking about the same kind of measurement. So if I was talking about dollars to gallons, there's no way I can make those be the same. But feet and inches both measure length. So I can first reduce this to 1/4 if you really feel like I need to do that. But then I'm going to multiply this by 1 foot within 12 inches. And what happens is all my units go away, so I'm just left with numbers, and that's what I want. So 1 times 12 is 12, and 4 times 1 is 4, and then I can reduce further. So my ratio, if we're talking 5 feet to 20 inches, my ratio is really 3:1, like when we're talking about size, which is really interesting because it looks like it should be the other way. All right, so hopefully that's helping you a little bit, or maybe you already knew this. All right, and then, of course, our good old word problems. Make sure, I would probably write this down. It's also in your book. A lot of these examples I pulled out of pages 356 and 357. A couple I might have tweaked a little bit, but you're planning to paint a mural, and it's going to be rectangle. So right away, I'm going to make a model to kind of work off of, and I'm told that the ratio is 9:2. All right, so because this is probably not 9 feet and 2 feet, I know that there's a number that can be multiplied against both of those. That's what that ratio means. So I'm going to make this 9x and 2x. I don't know how much that is, but I know that it's the same. They have the same ratio, or I'm sorry, they have that ratio of 9:2, so I know that's that same factor. And then I'm told that we got a perimeter of 484, which the perimeter formula is adding up all the sides. So I would set it up like this, and then combine like terms. So 18 plus 4 is 22x, and then you would solve. And finally, I'm going to let you do that on your own because I know that you can handle that. And then that just tells you what x is. Actually, maybe I do need to help you out with this because I want to make sure you have all the steps. So x actually equals 22. And so then that tells me, if I take this 22 and plug it back in here, that this side is 44, right? Because 2 times 22. And my other side is 198. And then the question is, what is the area? So my area is going to be 198 times 44, which seems really massive. It's 8,712 feet squared, because this is measured in feet. All right, then we have in the next example one of those deals where we have an extended ratio. We are told that the angles have a ratio of 2 to 3 to 5. So we're talking about a triangle, so I'm going to go ahead and draw it again. And I'm going to try it out the same way by saying that one of them is 2x, one of them is 3x, and one of them is 5x. And what do we know about angles? I know that they all add up to 180 degrees. So I can set up my equation that way and solve for x, and then I would take x and plug it in to each of these to find each of the measures of each individual triangle angle. All right, what else we got? All right, so how can we solve proportions? This is where we're going to spend a lot of our time practicing during class, so I want to make sure that you feel good about it, because some of you guys have practiced enough of this last year. But again, we're going to cross multiply. So I'm pretty sure this is 80 equals 9x. I got the extremes on one side. Here's my extremes. I got the means on the other side, or the mean. And now I'm going to divide both sides by 9. And what do I get for that? Some kind of decimal, right? 8.89 equals x. All right, Then I have another example where it just seems like there's y's all over the place. Let's start off the same way by cross multiplying. 3y times 1 is just 3y. And then I have 2 times y plus 1. Please make sure you are using those parentheses so that you can distribute and get these correct. So 3y equals 2y plus 2. Then I would go ahead and subtract 2y from both sides, and y equals 2. All right, and I don't want this video to be any much longer, so we can pick up together in class with this word problem, but feel free to copy it down first and have a good idea of where we're going. Maybe try it on your own. There's some strategies as far as setting a proportion. I like to put words. So what are the two things that we're comparing? Comparing the number of acres, and we're comparing it to the number of trees. So get some words together in a ratio, and then you fill in the numbers after it, and you solve. And sounds like a good place to stop. So hopefully this helped you out with how to set up some ratios and how to set up some, or not so much setting up proportions yet, but how to solve proportions. And if you have any questions, let me know.